So in this problem, we have to solve the improper integrals by using techniques of gamma function. So the first part involves an ln function, while the second part involves a square root function. And in all these two cases, to be able to find their solutions, we have to retransform so that they take the structure of the gamma function. So let's see how we do those transformations. So the first problem is to evaluate the integral from 1 to infinity of ln of x, ln of y power 3 divided by y squared and then dy. So you see on the structure of the gamma function, we do not have an ln function. And also the limits of integration are from 0 to infinity, not 1 to infinity. So which means that the given problem really is needs more transformations to be able to take the form integral from 0 to infinity y raised power, say, k minus 1 e raised power minus y dy, so that then we say this is defined as gamma of k. So then once we know that there's that problem, then we have to do some fixing to be able to get the structures of the gamma function. So say let u to be given by ln of y. Let's fix our u function to be that given part. So this means that the u will be given by 1 over y dy. So which means dy alone will be given by y du. Now, when we say that u is the same as ln of y, remember when we write an ln function, the base here is e. So this also implies that y itself is the same as e raised power u. So remember changing from logarithm form into index form, u equals to ln y. Remember the base here is e. So this statement actually has the same statement as y equals to e raised power u. So where there is y, we are allowed to replace by e raised power u, and where there is ln of y, we are allowed to replace by u, and where there is dy, we replace by y du. Now let's see what happens to the limits with this new variable. With this new variable, when y is 1, because that's the lower limit for y, then u will be given by ln of 1. And all of us know that ln of 1 is 0. So then we are happy that by this fixing of u equals to ln of y, then the lower limit will be 0, which agrees with the definition of the integral in the gamma function. And then when y is infinity, then u will be the same as ln of infinity. And as you make the value of y larger, then also the value of u will be larger. So this also be infinity. So therefore, limits, yes, the limits change. And the change of limits is actually in the correct form that our integral should be. So with those transformations, we'll have the integral from now 0 to infinity, not 1 to infinity, because we are now want to use this variable u. And then where is ln of y, we put u, so we'll have u power 3 divided by y squared. So y is the same as, let me just write y squared meanwhile, and then dy is given by y du, so that I'll cancel this y with one y here, and I have integral from 0 to infinity u power 3 du divided by y. But you see y is given by e raised power u. So we'll have integral from 0 to infinity of u power 3 over e raised power u and then du. And this can be written as integral from 0 to infinity of u power 3 e raised power now minus u du. And you see, we are seeing now the structure of the gamma function coming up. And to get the exact gamma function representation, just write this 3 as 4 minus 1. So we'll have the integral from 0 to infinity of u power 4 minus 1 e raised power minus u and then du. And this is nothing but gamma of 4. And once we have the gamma of 4, we always use a factorial function to be able to get the numerical value. So this will be given by 4 minus 1 factorial, which is the same as 3 factorial. And this will give us 6 as our solution. So therefore, the solution to the integral from 1 to infinity of ln of y power 3 over y squared dy has exact value of 6. So that's how you're supposed to solve that part. And then the other part is to solve the value of the integral from 0 to infinity of 2 square root of y minus e raised power minus y squared dy. So I'll have integral from 0 to infinity, this equation, 2 square root of y e raised power minus y squared and then dy. So to solve this, we also do transformation because this power of e is not in the correct form of the gamma function. So I'll say let u be given by y squared. So which tells us that u power half is the same as y. And from this one, du is the same as 2y dy, which means that dy is the same as du over 2y. So I rewrite this one as integral. Now let's see, before you do the rewrite, so let's see whether limits are changing or not. So when y is 0, then u will be given by 0 squared, which is 0. So lower limit doesn't change. And when y is infinity, u will be infinity squared, which will also still be infinity. So limits are unchanged. So let's now put in the values to change our integral purely in terms of the new variable y, the new variable u. So the integral 0 to infinity of square root 2 square root of y e raised to power minus y squared dy will be given by, actually I can factor out 2. And then where they saw, remember this square root of y. So square root of y is the same as writing y power half e raised to power minus u and then dy. So this 0 to infinity, which is 2, 0 to infinity. Now, y alone is given by u raised to power half. So this is the same as u raised to power half, and then u raised to power half, e raised to power minus u, dy is the same as 2 du over 2y. So which is the same thing as saying we have, so these two and these two cancels out. So we'll have 0 to infinity, u raised power quarter, e raised power minus u, and then du over y alone is the same as u raised power half. So which is the same as integral 0 to infinity. Now using properties of indices, so a quarter minus a half will be the new power of y, which will be given by minus 1 over 4. So we'll have minus 1 over 4 e raised power minus u and then du. Now we rewrite this power minus 1 over 4 in the form of n minus 1. So this tells us that n is the same as 1 minus 1 over 4, which is 3 over 4. So therefore, this integral can be written as integral from 0 to infinity u raised power 3 over 4 minus 1, and then e raised power minus u du. And that is the structure of the gamma of 3 over 4. So this will give us gamma of 3 over 4. And remember the question wanted us to express our answer in form of a gamma function, and where, so this was the way we are supposed to write our answer, where alpha is a rational function, a rational number, a rational constant. And indeed, 3 over 4 will be the value of the constant alpha. So therefore, the final solution of the equation, so simply say the integral from 0 to infinity of twice square root of y e raised power minus y squared dy is nothing but gamma of 3 over 4. So this is the solution.